these are differential equations which are separable. And for separable differential equations, you always write dy dx instead of y prime. And you try to first multiply the dx to the other side, so that dy is 8y. And then once you have dx and dy in both sides, you try to move all the y's to the one with dy and x's to dx. And I see that y is here, that should go over there. And when you move things, you should only multiply or divide. Because dx is multiplied, you may not add or subtract. That's not going to move these parts. Okay, so always either multiply or divide. So what I'm going to do is I'm going to multiply by 1 over y both sides, because then this and this will cancel, and now you will have y on this side. And that's nice because now you can integrate. Integral of 1 over y is ln of y. When you're solving differential equations, you don't need the absolute value, so it's okay. And also you only need to put plus c on one side. Okay, so that's almost the solution. We still have to solve for y because we're looking for y as a function of x. So we exponentiate both sides. These cancel and you get y equals to e to the 8x times e to the c, and because c is some arbitrary thing, you can rename this as the c. Or if you don't like what I mean by rename, let's just call this as c tilde, okay? And this is some arbitrary variable, so I can just call this e to the c tilde as c. It's still some kind of constant, right? So then we can just say this is c times e to the 8x, and that's the final answer. Okay, let's do the next one. This one, again, we use the same principle. Dy dx is equal to y times 3 minus y, and then you multiply dx to the other side. You get y 3 minus y dx, and then since you have y's here, that should go to this side, so you divide by y, and then you integrate. Okay, the right side is just integrating a 1. You should think of dx as 1 times dx, so the right side is just x plus c. What's not so clear is how do you integrate this? And the hint here says try simplifying this into a single fraction. Okay, so let's see what that hint gives us. So let me change some colors just to, okay, so it's easier to distinguish. So if you do 1 over y plus 1 over 3 minus y, you need to, in order to make this into a single fraction, you need common denominators. So I'm going to multiply 3 minus y to the first fraction, and for the second fraction I'm going to multiply y and y for the second fraction, so that they both become y times 3 minus y as the common denominator. And the result is that you get 3 minus y plus y, whereas y cancels, and you get 3 over y times 3 minus y. Now, this is interesting because we have 1 over y times 3 minus y, and that's just the only difference between what we have here and here is that you have a 3, right? So here's another way to think about it. If you have 1 over y times 3 minus y, that would be like 1/3 of 3 over y 3 minus y, and we just figured out that this is same as that, right? So it's 1/3 of 1 over y plus 1 over 3 minus y. Okay, so how does this help us? Well, if you integrate this, then 1/3 can come outside the integral, and you can replace this thing as this, which is now something easier to integrate. See, this one, it's not a straightforward easy integration. If you have a fraction, integrals become really hard if you have a fraction. So what you can do is you can now integrate this separately and say this is 1/3. Integral of 1 over y is ln of y, that we all know. And the problem is, how do you integrate 1 over 3 minus y dy? So let's continue. Actually, this happens to be a very long question. So if you have 1 over 3 minus y, then you have to do u substitution. U equals to 3 minus y, so that du equals the derivative of 3 is 0, derivative of negative y is negative 1, dy, so that dy would be negative du, and that transforms this integral into 1 over u times negative du, and 1 over u just integrates to ln of u, right, with a negative 1 being a constant multiple, so that can be brought outside, so it's negative 1 times ln of u plus c, where ln of u is ln of 3 minus y. Okay, so knowing this, now we have a full description of what integral of 1 over y times 3 minus y is. This is 1/3 of integral of 3 over y times 3 minus y dy, and it's 1/3 of integral of 1 over y plus 1 over 3 minus y. These two are algebraically equal, so I can replace one by the other. And these I know the integral of. This is 1 over 3 ln of y, and 1 over 3 minus y, we just figured out that this is minus ln of 3 minus y, and then that's the left side. And remember, the right side is x plus c, right? So here, let's try to simplify by multiplying by 3, and we get ln of, and then subtracting 2 logs is division, so y over 3 minus y equals to 3 times x plus 3c. You take exponents, which gives you y over 3 minus y equals to e to the 3x, and e to the 3c can be now renamed as c. We do this quite often. And you still have to solve for y. And I mean, this would be a pretty nice way to write down the answer. But if you really want to solve, then you can flip this, both sides, and we get 3 minus y over y as 1 over c times e to the 3x. And this is what? This is 3 over y minus 1, so you can add 1 both sides. So that gives you 3 over y equals to 1 over c e to the 3x plus 1. And then finally you can flip both sides again. Oh, that's quite frightening, but if you flip both sides and multiply by 3, you end up with y, well, if you just flip, then it's 1 over c e to the 3x plus 1. And then you multiply by 3, this will be 3. And finally, you can multiply c to the 3x just so that this becomes simpler. And that gives you 3c e to the x divided by 1 plus 3c e to the x. 1 plus, not 3c. There shouldn't be a 3 there. Okay, and that's the final answer. So that last bit of algebra was a little tough. However, I do want you to know how to solve this, because this is an example of a logistic differential equation. So this has a name. This is logistic differential equation, and if you look at the textbooks, you'll see that most textbooks deal with this because it appears in some very interesting natural phenomena. So that's why, even though this is quite complicated, I still want you to be able to do it. Okay, now the rest of them are pretty typical differential equations. X, y, y prime. Remember, we decided to write y prime as dy dx equal to 1. So if you have y dy and multiply dx to the other side, and I need to multiply by 1 over x so that you get this, and then that's how you get it separated. And then you integrate both sides. This is 1/2 y squared. This is ln of x plus c. So multiplying by 2 gives you 2 ln of x plus 2c, but we'll just rename this as c. And then taking the square root, you get y equals to plus or minus square root of 2 ln of x plus c. Now this time you have a initial condition, so we have to make sure that it's satisfied here. This means that when x is 1, y is 2. So that's how you understand this initial condition. So we're going to plug in 2 into y and 1 into ln, 1 into x, so you have ln of 1. What's ln of 1? That's 0. So 2 equals to plus or minus square root 2 times 0 plus c. Oh, by the way, this immediately tells you that minus can't happen, because if it's minus, then you can't have plus 2, right? So that actually says that this negative cannot work. If this initial condition was y of 1 equals to negative 2, then you would have chosen the negative one, okay? And then you square both sides, so it's 4 equals to 0 plus c. 2 times 0 is 0, so it's 0 plus c, so you end up with c being 4, and then you have to plug it back in here, so the final answer is y equals to square root of 2 ln of x plus 4. That's the answer. Okay, part D, similar thing. You multiply dx both sides, and now I see that this should be on this side, right? So you divide by square root of y, and now you integrate both sides. And when you integrate, this should be written as a power, because or else you don't know how to integrate. So this is y to the 1/2 power, but because it's in the reciprocal, this is y to the negative half power, and you're integrating this, which means you add 1 to the exponent, which is positive 1/2, put the reciprocal of that, which is 2 over 1, and that is going to be equal to the integral of sine, which is negative cosine, plus c, and then divide by 2, so it's y, and y to the 1/2 power is square root of y, right? Negative 1/2 cosine of x plus c. I should really be writing c over 2, but then I'm renaming it, okay? And then we have to solve for y, so you square both sides, so it's negative 1/2 cosine of x plus c squared. And here, this means when x is 0, y is 5. So let's try that. Y is 5 when you have negative 1/2 cosine of 0 plus c squared. Take the square root both sides, so you have square root of 5 equals to negative 1/2. Cosine of 0 is 1 plus c, so c is equal to square root of 5 plus 1/2. And that's fine. All you have to do now is to plug that back in here, and therefore the final answer would be y equals to -1/2 cosine of x plus radical 5 plus 1/2 squared. Okay, now the last question, multiply by dx both sides. Here we don't have an initial condition, so we just have to solve this. That's nice. Okay, and then you divide both sides by 1 over y, because if you multiply by 1 over y, then this cancel and you only have x with dx, perfect, and y with y. So that's good. dy with y, that's perfect. So now you integrate both sides. Integration of x is 1/2 x squared plus c. For this one, we will require u substitution. U equals to 1 minus y. Du would be derivative of 1 is 0. Derivative of -y is -1 dy. And then you now solve for dy. So dy is -du, which brings this integral into integral of 1 over u. -du. -1 can be pulled outside. And integral of 1 over u is ln of u, and ln of u is what? U is 1 minus y. Okay, so after putting the left equal to right, this is what I get. I get negative ln of 1 minus y. You should put c only on one side, so you get 1/2 x squared plus c. And we have to solve this for y. So multiply -1 both sides. So you have ln of 1 minus y equals to -1/2 x squared minus c, but we don't care. We just rename the minus c as positive c. And then we exponentiate both sides so that these cancel and you get 1 minus y equals to e to -1/2 x squared times e to the c, and now we rename this as c once again. And then you move this y to the other side, move this to the other side, and the final answer is 1 minus c times e to the -1/2 x squared equals to y. And that's the final answer.